In this movie, we're going to look at how you show decisions in activity diagrams. We'll look at the two kinds of control node used for decisions, that is, decision nodes and merge nodes, how the conditions and guards are shown, and how you can show decisions without these special nodes. An activity diagram models a workflow at some level, and it's possible for workflows to branch based on conditions. These could be human decisions or automated decisions. In a UML activity diagram, the flow branches at a decision node and merges back again at a merge node. We show both of these with diamonds. Depending on the modeling tool you're using, the decision node can have the decision or condition shown in it or near it, and it can also be shown in a constraint attached to the node. The flows out of the decision are marked with guards, and the flow of control will follow the first guard to evaluate true. Here's a diagram showing a decision and a merge. The decision has one flow into it and multiple flows out. The merge has multiple flows into it and one flow out. The name of the decision, which usually summarizes the condition that's being tested, is shown in or near the diamond. It's also possible to show the condition as a constraint, as here, with the stereotype decision input. And the guards on the flows out of the decision show the alternative possibilities from evaluating the condition. UML doesn't specify the order in which the guards will be evaluated. Only one flow out of the decision node should be enabled, so it's important to ensure that the guards are mutually exclusive, otherwise the outcome is potentially non-deterministic. They should also cover all possibilities. Rather than showing the condition in a separate constraint, the guards can show the full condition, and the flow of control will follow whichever evaluates to true. If you're testing for one condition to be true and all other cases follow another flow, then you can use the keyword else. In this case, if the number of faulty devices is anything other than greater than 0, the else flow will be followed. It's possible to not use decision nodes. Showing guards on the flows out of an action or activity mean that the flow whose guard evaluates to true will be followed. The flows still have to merge somewhere. If you have two flows into an action, they both need to be enabled for the action to execute, so you still need a merge node. It's also potentially more difficult for the reader to understand, as there are no obvious signs of a decision in the form of the diamond-shaped decision nodes, but it does take up less space in the diagram. Let's add these decision and merge nodes to a diagram in EA. So what we're going to do now is we'll use the activity diagram for query device and sensor status, which we'd use to specify the use case of the same name. I'm going to add a decision node before remove faulty devices. I need to make some space in the diagram. Now I can click on decision in the toolbox and then click on the diagram where I want it to appear. I'll call the decision faulty devices exist with a question mark on the end. It's an informal way of expressing what this decision node is testing. Now I can take the control flow that was connected between the two activities and connect it to the decision node. If you select a connector in Enterprise Architect and then click and hold the mouse button down on one of its ends, you can move that end to another element in the diagram. You'll see a dashed line appear all round the inside of the element when you move the end of the connector into it. Now I'll add the control flow out of the decision node for the true case and connect it to remove faulty devices. It's a control flow. The other flow will need to go to a merge node, so I'll add a merge node, which doesn't need a name. I click on Merge in the toolbox and then on the diagram. Then I can connect the other flow to that merge node, so I'll add that flow next. In Enterprise Architect, clicking on the Shift key as you create a connector allows you to add bend points into that connector as you go along. Now I'll move the flow between remove faulty devices and remove faulty sensors and connect it to the right-hand side of the merge node. And I'll add a new flow from remove faulty devices to the merge node. Again, it's a control flow. In this case, I'll add a constraint to the decision node. I right-click on the decision node and select New Child Element and then Attach Constraint. The type of the constraint is going to be decision input. And the constraint is the condition that controls this decision, which is number of faulty devices is greater than 0. Now I can add the guards to the two flows. I open up the dialog box for the first, and I go to the constraints page. See, there's a field here for guard. I'll enter true for this one. I do the same for the other one, and I enter false. So I've added a decision with two flows that have guards on them. Decisions can also be used to create loops in diagrams. Let's look at the activity diagram for directly control a device via browser. What happens when the user gets to the end of this workflow? He or she may want to switch another device on or off, or open the blinds or whatever. The program could prompt the user for the next action, and then go back to an earlier point in the activity diagram if he or she wants to control another device. So I'll extend this activity diagram, and I'll add another activity after control device. I'll call this prompt for next action. Now I'll add a decision after that and before the final node. I'll call it next action with a question mark on it. Now I'll connect a control flow to the final node and a control flow from prompt for next action to the decision node. So if the next action is another device, it needs to loop back round to display list of devices in room. I need to add a merge node before that for the flow to merge with the original flow. I can select multiple elements in a diagram by holding down Control as I click on them. So I'll add the merge node here. Again, it doesn't need a name. And I'll connect it into the flow with control flows. Now I can connect this decision node with a flow that goes back to the merge node. And I can put a guard on this and say action equals another device. So if when prompted for the next action, the user selects another device, then it loops back round here, displays a list of devices in the room, allows the user to select another device and control it directly. I just need to add an else as a guard onto that control flow out of the decision node, and we're done. So we've used decision and merge nodes in two different ways in activity diagrams. In the first case, to model a decision where one of two or more paths is taken through the workflow, depending on a condition, and in the second case, where a decision is used to control a loop.